All right, so 2.4, we're still working. We're starting out our proofs. On Friday, we did an actual equation, solved it for x. So we had all of our steps here, and then we had all of our reasons, right? Okay, we're going to pass on that. We're going to skip that. That was part of our explorations. We have that done. You should be able to solve an equation now and be able to tell me why you did each step. Okay, whether you added to both sides, divided, whatever it be, you should be able to handle that. So I want to look at example 3 on page 93. I usually do your extra example. I'm going to do the actual example so you can follow along because it's kind of a longer word problem. Okay, this problem says you get a raise at your part-time job. To write your raise as a percent, use the formula P times R plus 1 equals N. Okay, so as you read through that, that's our given information, right? They gave that to us. So if I were setting this up in a proof, P times R plus 1 equals N. And what would I put on the right side for how I knew that? That was given to me. And that'd be step 1. Okay, so there's my given information. In a proof, the first row will always be given, right? Okay, otherwise there's no way you know how to start it, is if you don't have that given information. Okay, so there's got to be a way to start it, and that's with our givens. Okay, then it goes on and tells me P is your previous wage, R is the percent increase as a decimal, and N is your new wage. Solve the formula for R. Okay, so that sentence telling us what each variable was at this point doesn't really matter, because first they want us to solve for R. Okay. I'm going to show you a little bit differently than the textbook shows you, because I think I know my way's shorter, and it ends up being the exact same thing, so hopefully it's easier. So when they tell me to solve for R, that means get it by itself, correct? Okay. What's the first thing you guys would do? Would you distribute? That's what the book did. The book distributed, which is fine. You will get to the same answer. I wouldn't distribute because I'm trying to get that P to the other side anyways, right? So I'm not going to waste my time keeping it on this side. You with me? Since it's being multiplied to this whole thing, I can just divide by P right now and get rid of it off that left side. Agreed? Okay, so that's what I would do. The book did distribute, like some of you said. So once I divide, I end up with R plus 1 equal to N divided by P. What property did I use there? The division property of equality, because I did divide by P on both sides, right? Okay. So now I can keep going. I'm trying to solve for what? R in this case. They said solve for R. Solve for R. So I need to get rid of 1. How do I do that? Subtract it. So R equals N over P minus 1. And what would my reason there be? Subtraction. Okay. Am I done? Did I solve for R? Yes. Now I haven't plugged anything in yet, but I have solved for R because I have R by itself. Okay? Okay. Does that match exactly what they have in the book for R? No. We can all agree that it does not, right? Okay. Let me change some things on what we have and see if you agree with everything I do. I can change this 1, or this minus 1, to a minus P over P. Because P over P is just 1, right? Anything over itself is equal to 1. Okay? And since there's a P in both of these denominators, I can just write it as 1. Put that minus sign back up here. Now I have the exact same thing they have, right? So technically, that is exactly what they have, right? It's just written in a different form. Okay, so it doesn't matter if you want to distribute that P, you sure can. I think it's extra work and not necessary. Okay? And the way I have this written, I have less places to plug things in at too. Okay? So whatever way is fine. They're both correct. They get you the same answer. Okay? Now, then we go on. Now they want us to find the actual percent increase, which we know is R. They tell me that my old wage was $7.25 an hour, and my new wage is $7.54 an hour. Okay, so I can plug those things in. What's N stand for again? What did we say? My new wage, which we just said was $7.54, and P stands for my previous wage or my old wage, which used to be $7.25 minus 1. What did I do there? What would my reason be if they wanted a reason for that? I haven't simplified yet because I haven't combined anything. What's it called when I plug things in? Substitution, because that's all I did, right? I plugged things in for my variables. So I substituted. Okay. And then last step, step 5. Hopefully a few of you have a calculator. Go ahead and solve that out. See what we get. What does R equal? .04. Did everybody else that solved it get that same thing? Take that as a no. Did you just do this? That divided by that and then subtract 1? Oh, there's a button you can push to change it to a decimal. Okay, I'll show it to you in a little bit. Okay, you should have got .04. What would my reason be? Did I combine a bunch of like terms there? Simplify. They're all constants, right? Okay. So the question is, what percent increase was it? 4% increase. Okay, so I got a 4% raise. Okay. Now, the other thing I want to tell you about this problem, first of all, our problem specifically said solve for R first, right? Okay, in the directions, that was the first thing it said, solve for R. If it doesn't tell you that you have to solve for R, and it does not want this equation at some point, would it be possible, that's not going to let me copy that, would it be okay if I just took my 7.25, plugged it in for P, 7.54, plugged it in for N, and solved? If they didn't want me to solve for R first, would I get the same answer? You should, right? Because you're still solving for R. So let's go ahead and show this real quick. Divide by 7.25. Divide by 7.25. So now I have R plus 1 equals 7.54 over 7.25. I would subtract my 1. Isn't that the exact same thing you just typed in your calculator? Yeah. Okay, so what I'm getting at is if they don't specifically tell you to solve for R as an expression or as all variables, could you plug in first and then do all the work moving things over? Yes. I don't care which way you do it unless they specifically ask you for this. If they specifically ask you for that, you're going to have to do that, right? Okay, so just be aware of that. All I care about is that you can get to the right answer. Okay, which way you do it, I don't care. If you can get the right answer, then you can get the right answer. That's what matters. That's being able to come up with the correct solution. Okay. Now, we're going to, from here, we're going to go into some actual proofs that have to do with angles and segments. Okay, so this will probably be entirely new to you and something you have never done before. So go ahead and flip the page. We're on page 94 now. Okay, again, I'll remind you the reflexive, symmetric, transitive properties are at the top of the page there for you if you need to refer back to them. The example I'm going to do you don't have. Okay, so pay close attention. Make sure you get it copied down. What they are saying is that I have a pool table. Okay, that's one side of the pool table. And I take a pool ball, 8-ball, and I shoot it, and it bounces off at point T. That's R. That's S. I believe this is P and Q, how they have it labeled in my book. Yep. Okay, is everybody following what I got drawn here? Shoot this ball, bounces off here, goes here. Okay, and then they label these angles as angles 1, 2, and 3, just so we can refer to them easier without a bunch of letters. And they label that this angle, RTQ, is the same measure as this angle, STP. Okay, so here's our given diagram. They want us to prove that angle RTP is equal to angle STQ. Okay, I'll give you a minute here to get that copied down. All right. Now, one thing that we need to talk about that we probably haven't really discussed a lot, and maybe you figured it out yesterday as we were doing this. When you're doing a 2-column proof, the very first row is always going to be what information? Your what? Your given. Always, right? Because without given information, you have nowhere to start. Agreed? Hey, you got to know something to be able to get this thing rolling. Okay? Your first step will always be your given information. Okay? Your last step will always be whatever it's asking you to prove. Okay? Makes sense, right? If you're solving an equation, they say solve for x. What's your last step? Well, it's always x equals blank, right? Okay, same thing here. This is like what we're trying to solve for. This is what we want to be our very last thing. Okay? So looking at this diagram, and actually before I do that, is it okay instead of RTP if I just say angle 1 equals angle STQ, which is angle 3? Can I do that? Since they're labeled? Yeah. Okay, that'll just make it easier so you don't have to write letters all the time. So looking at the diagram, sometimes it'll be written or told to you in a sentence. Sometimes you'll have to go to the diagram and pull the given information. What in the diagram did they give us? What did they mark for us that has to be true? Okay, so angle 1 plus 2, which would be RTQ, right? So they told us that angle RTQ has to be equal to STP, correct? everybody with me on that? Okay, and again, don't think that I'm just expecting you to be able to bust this thing out on your own. Okay, this is probably one of the harder concepts we'll do in geometry is setting up and solving proofs. Okay, so we'll go through them slowly and we'll take our time and you'll slowly get better at them. So don't be discouraged when you are trying to figure out what the heck is he talking about because I don't know how he got that. Okay, just ask questions. Okay, so that has to be true. Okay, the next thing I like to do is I like to look at my given statement and my prove statement and figure out, do I already have some things that I need in the end? Well, in the end, do I need RTQ at all? No. In the end, do I need STP? No. Okay, so we have some information here that we either have to get rid of or change into something else somehow. Right? Because we got to change it into RTP and STQ. So, the next thing I would do is go to this angle RTQ, find it in your diagram, and see if there's another thing you can tell me about it. Maybe what it equals sometimes, what it's formed by, what it consists of. Not necessarily any, there might not be any right angles. Okay, RTQ is? Okay, but remember supplementary is only 2 angles. I like what you're thinking though. You will have to think about supplementary and complementary at times, but not in this problem. Just look at RTQ. What 2 angles does it consist of? Angles 1 and 2, right? Everybody can agree with that? Okay, RTQ is formed by angles 1 and 2. Okay, so I can say that angle RTQ is equal to, I don't want to say angle 1 and angle 2, but I want to say angle 1 plus angle 2. Good. So this is thinking back a few weeks, 2 or 3 weeks. What postulate said that I can add 2 angles together to get a larger angle? Angle addition postulate. Okay, and this is where, remember the other day I recommended that you make a list of postulates in the back of your notebook? As you're doing assignments, if you can't figure out where to go, you could quickly scan through those and see if maybe that gives you any hints. Okay, so now I've used angle addition postulate. Would it make any sense to use segment addition postulate in this problem? We started with angles, right? And we're ending with angles. So you're probably never going to use anything about any segments in this problem. Okay? So I know I'm getting somewhere because I now have angle 1 in my problem, which is part of my solution, right? Okay, so I got angle 1 in there. So I know I'm at least getting somewhere that's going to benefit us. We said we don't need STP either. Is there something I can say about angle STP? STP is equal to angle 2 plus angle 3. Do we agree with that? Okay. Why? What's my reason? Angle addition postulate again. I'm not going to do an extra number for that, so I don't have to write it again. In your assignment, they would probably break that into 2 steps. Okay, but you don't need to if you don't want to. Okay. Now, I'm going to scroll down here. Don't write this next thing that I'm going to write. If I were to just randomly give you an equation, and then just tell you that x equals 4. Without even telling you what to solve for, what's probably the first thing you would do? You probably plug it in, right? Hey, you guys have been drilled on that. You've been trained on that. You know if x equals 4, then let's plug it in, right? Up here, I gave you an original equation, And then I told you RTQ equals 1 plus 2. What do you suppose I'm trying to get you to do with RTQ? Instead of RTQ, I'm wanting you to plug in what? Angle 1 plus angle 2. I want to take this, and I'll plug it in right there, because I know that's what RTQ equals. Okay, just like on the last thing I showed you. You knew what x equaled, right? So you wanted to plug it in. I know what RTQ equals, so let's plug that in for RTQ. Okay? So if I'm substituting that in, what's this next step going to look like? Instead of RTQ, I'm going to write, good, angle 1 plus angle 2. Again, these are things that as we do more and more of these, you're going to start seeing them. Okay, I wouldn't expect you on the very first one here just to automatically know what I'm wanting you to do. Okay. But now that got rid of RTQ entirely, right? Which we said we were going to have to do. I also said I got to get rid of STP. It equals angle 2 plus angle 3, so let's plug it in for that, right? What did we just do? What would our reason for this be? Substitution. Okay, I like the thought of the addition because we are adding on both sides. But to get from here to here or here to here, we plugged in, right? So we use substitution. Okay. Now we are getting close because now I'm at a statement with 1 on the left side and 3 on the right side, which is good because up here I have 1 on the left and 3 on the right. Problem is I still have some extra stuff in here. What am I talking about? That 2, right? Those 2's. Somehow I got to get rid of them. Let me show you this. Don't write this down. What if I had this? What if I had this? What could I do? Okay, I could, or I could subtract 2x, right? What happens if I subtract 2x? The x's are just gone completely, right? So what happens up here if I subtract 2? Angle 2. They just disappear, right? Since it's the same on both sides, I can just subtract angle 2, and it's just going to go away, right? Okay. Exactly. So now, once I subtract that, I have that angle 1 is equal to angle 3. What property did I just use? I used subtraction, because I subtracted angle 2 from both sides. Am I done? Is that exactly what we were trying to prove? Angle 1 equal to angle 3? Yeah. Angle 1 equal to angle 3. We wrote it a little different. We wrote it with numbers instead of letters. But it's the same thing, right? Okay. The next thing, there's 2 parts of a proof you should absolutely never, actually 3 parts. You should never ever miss them. You should never miss that part because it's given to you. You should never miss this part because it's always going to be the word given. And you should never miss this part because that's always going to be what you're trying to prove. Okay? The middle stuff's the hard part. Okay? And you'll slowly get better at this as we work through it. Okay? Just take your time on these. Okay? Be open to the idea of learning how to do them and the fact that they will be a little bit challenging. Okay? It's just how it is. It's okay to challenge yourself. With us, William? Okay. I want to do one more of these before I let you loose on your homework. This one, you need to pay very, very close attention to because, well, first of all, it's a proof and we're doing the example. Second of all, I can guarantee you, You see that this proof or something very, very, very similar to this proof at least 5 more times after I show it to you today. You'll see it once on your chapter test. You'll see it once on course benchmark 1, once on course benchmark 2, once on course benchmark 3, and once on the post assessment at the end of this year. Okay? I promise you. If you don't believe me, you'll figure it out. Hey, you need to know this one. This example, and they'll probably switch the words around you on the tests and things, but the diagrams will be about the same. It says there are 2 exits from Theater 10 at a local cinema. The cinema manager wants to put a trash can along the wall, exactly the same distance from each of the 2 exits. Create a diagram to model this problem. That's the first part. Well, how many exits do I have? 2. I have exit A, or whatever you want to label it, and I have exit B. Okay. What are we trying to do, or what's the manager trying to do? Put a trash can in the middle. Okay, I'm going to label it T for trash can. Oops. It's kind of a poor diagram, but it'll work. Okay. Since it's in the middle, what else has to be true? Okay, it bisects, meaning that AT is the same distance as BT or TB. Agreed? So there's our diagram. That's what we're trying to do. Okay. Now, obviously, in a real-life scenario, you're going to get out a tape measure or something like that and measure it, right? That's not the point of this real-life problem. It's being able to use geometric definitions, postulates, properties, things like that, to show that this will be true every single time if I did this. Okay? What they want us to prove is they want us to prove that the distance from the trash can to the left exit, which would be what segment? AT, segment AT. They want us to prove that AT is, which means, in math, what's is mean? Equal, good. Exactly half of the distance from one exit to the other. Okay, so half, and then what segment is from one exit to the other? AB. So that's what they're trying to prove. Meaning that's going to be the very last step in my proof, right? Okay. What will be my very first step, or my given information based on this diagram? AT is congruent, or I'm going to use equal because we haven't talked a whole lot about congruent in proofs yet, but they use equal, so I'm going to use equal. AT equals TB. Okay, everybody agree that that's given to us in our diagram? All right. Now, remember, this is where I recommend starting every single time. Look at your given. What does it have or does it not have in our proof, right? Okay, well, I see this has AT. That's good because so does this, right? So that will probably never change as we go through this problem. Or we won't get rid of it anyways. I also have TB. That's bad because I don't have TB over here, right? Okay, so I either have to change it or add in AB, because I need AB in my problem somehow, correct? Okay. So looking at this, I don't see any way where right away I can change what TB is. Okay. So we're just going to go here to step number 2, and let's just try to add in AB. Is there something you know about segment AB? It's what? It's from one exit to the other. True. William? Exactly. AB is equal to AT plus TB. Does everybody agree with that? If I were you, I would recommend looking for angle addition and, what's this called? Segment addition as much as possible. Okay, they will be very helpful and they will be highly used. Okay, this would be the segment addition postulate. I took two smaller segments, added them together to get the larger segment. That's one of the most common ways to get a segment or an angle into your proof that you don't already have in there. Okay, so look for those, segment addition and angle addition, depending on what your diagram looks like. Okay, that's good because now I have AB and AT in the same equation, which I know I'm going to eventually need, right? Problem is I still have this TB over here. Okay, looking at steps 1 and 2 though, is there a way to eliminate TB? What do you know about TB from step number 1? It's equal to AT, so what can I do there? No? Okay, let's think back to this. I have 2y equals 4 plus 3x. And I tell you that x equals 2. You would do what? You'd plug it in. Up here, I have that AB is equal to AT plus TB. And then I told you TB equals AT. What should we do, William? Okay, I don't want to do that yet. That's skipping a step. Okay, I want to change this into AB equals AT plus, but instead of TB, I'm going to plug in AT because they're equal to each other. So I can plug in one for the other if I wanted, right? So what would I say I did? Substitution. Okay, now one of the most common questions I get right there is how did you know to plug in AT for TB and not TB for AT? How did I know? Yeah, I need AT, right? I don't need TB. I want TB gone. So I'm going to get rid of it by plugging in another AT. Okay, so I know that based on what I want to prove and what I need in my final statement. Now going on, William was one step ahead of us. Going on to step 4, if I were to have, sorry I keep scrolling up and down, but I can't write on the whiteboard because of the video. If I had y equals x plus x, what does y equal? Well, but what is x plus x? 2x, right? Can we agree with that? A y equals 2x then. I have kind of the same thing, and I know I keep going back to algebra expressions because that's kind of what we understand. I have AB equals AT plus AT. So AB equals 2AT. Right? I just combined my like terms. Hey, if I just told you I combined my like terms, what do we talk about our reason better be? Simplify. And you were gone for when we did that, Casey, but to use addition, you got to do it to both sides. It's the addition property of equality. That would have to happen on both sides. This was just one side where I combined like terms. That's just simplifying the expression. Okay. Okay, well, we're getting close because I got rid of my TB, but up here AT is all by itself. Okay, down here it's not. How do I get AT by itself here? divide it by 2. So when I divide this by 2, like so, right? I get AB over 2 equals AT. And what property was that we just used? Division. Okay. Now, I want you to pause right there, and I need you to understand something, and you should understand this already, hopefully. But I need you to make sure you understand that this, AB over 2, is the exact same thing as 1/2 AB. Does everybody understand that concept? Okay. Multiplying by a half and dividing by 2, those are the same thing. Okay, so instead of writing AB over 2, I could write this as 1/2 AB because I know that's how they have it in my proof. Okay, so that would still be your same division step. Just understand that it means the exact same thing. Dividing by 2 and multiplying by a half is the same thing. Do I have exactly what they have for proof? Not yet. Emma, what do I need to do? I got to switch it, right? Okay, so let's start there. AT equals 1/2 AB. Does anybody remember that property? That's the symmetric property. Good. Again, we will use that property and talk more about that in depth in the next lesson. Are we done? Did we get exactly what they wanted? Yes. Now, just like I said earlier, I don't expect you to be perfect at these yet. You have literally never done anything like this before in your life, right? Okay, you can't roll in here on day one and expect it to be perfect. So take your time, ask questions, be open and willing to work on these. Any questions before I let you get to work? Yes?
How did you get the 1/2 AB?
It's the same thing as multiplying by 1/2 AB is the same thing as taking AB and dividing it by 2. I just wrote it a little bit differently because I knew how they wanted it. Does that make sense? Okay. All right.